All right, friends, as you can see, we have moved on to Module 4, Lesson 6. And what we're going to be doing in this lesson is actually learning how to measure our angles with a protractor. Now, we have a variety of protractors we can use. Before we begin measuring, I wanted to introduce you to the fact that you must know, beyond anything else, that a circle contains 360 degrees. We've already discussed this, but you have to remember that an entire circle is 360 degrees. And angles are just parts of a circle. So first thing we're going to look at is what different protractors look like. The first protractor we have is a circular protractor. With your circular protractor, you have your center midpoint, and I have taken my pencil and put a hole in it, which you will be doing as well. You will notice that my 0 degrees I have facing off to the right. The reason for that is because you want to line up this 0 line on the bottom line of your angle. And you'll notice this is 90 degrees at the top. We could essentially put our square in to represent 90 degrees. A straight angle all the way around is 180 degrees. And then as we get wider, we go to 270, and then an entire circle is 360 degrees. Another type of protractor is a half protractor. You will notice with this half protractor that down at the very bottom is a cross point right here. And you want to make sure that your numbers actually are readable. So 1, 2, 3, 4. You have this cross point. Right where the 2 points meet on this perpendicular point, that's what you line up on the vertex of your angle, where your 2 lines connect. You notice that this is 90 degrees, right at the dead center, and a straight shot would be 0 degrees, straight across this line right here. And on the other side, being a straight angle, this straight shot, even though it's not labeled, would be 180 degrees. And you can see that because this is 170, so next would come 180. 10, this would be 0. Now you'll notice that this has 10 through 170 on the bottom and 10 through 170 on the top. We're going to discuss that later. And the last protractor I have, which is one of my personal ones I have at home, yes, your teacher is a nerd, she has protractors at home. Same situation, we have our cross point here, but it's just one straight line going down vertically. We are at 0 degrees here, which is the same as 180, and 0 goes all the way up to 90, which is that dead center point. If I went straight over to 0, straight up to 90, it'd be a 90-degree angle, and it comes all the way over to 180. Now, you'll notice that this one also starts at 0 and goes all the way over to 190 on this end. Now, they have 350 here and 350 here. Not 100% sure why, so we're just going to disregard them until we figure it out. So what you guys are going to get is you're going to get a practice sheet that looks like this, and you're going to spend time measuring them. I'm going to give you some steps you must do first. Step number 1 is always ask yourself, is this an acute angle, an obtuse angle, or a right angle? If you can answer that question, you're already headed in the right direction. Once you answer that question, step number 2 is, well, how many degrees are generally in an acute angle? Well, that's 0 to 89. 0 degrees to 89 degrees. Really, it's just 1 degree to 89 degrees. Obtuse would be anywhere from 91 degrees to 179 degrees, and then 181 degrees to 360 degrees. You'll notice I skipped that 180 because 180 is straight. And then, of course, your right angle is 90 degrees. So why don't we go ahead and throw that straight angle on here, which would equal 180 degrees. So once you ask yourself step 1, figure out step 2, and then step number 3 will actually be to measure. Let's go ahead and do that. This is the protractor you're going to spend a lot of time with, so I'm actually going to start with this one. I'm going to take my perpendicular space, my perpendicular lines, and I'm going to find the little vertex. And I'm going to put it right on the vertex of my angle. So if I do that, you can barely see it, but this one line is protruding. My other line is protruding straight up, and if I did it right, my other line is directly on my 0, which it is. If this is the 0 line, that's what we said this piece was, is it followed 10, went to 0. All right. I ask myself, is this an acute, an obtuse, a right, or a straight angle? Well, it's obviously less than 90 because we know 90 would be straight down and straight over. Therefore, it's acute. So I know it's going to be between these 2 degrees. So when I put my protractor on there, line it up, I have an option. It could either be 60 or 120. But since I know it's acute, it has to be between these 2 numbers. And what falls between them? 60 or 120? Well, obviously it's 60 degrees because it's an acute triangle, or acute angle rather. Now let's go ahead and look at D. Let's follow our steps. Step 1, acute, obtuse, right, or straight. Well, we know a right goes straight up, and we know acute is smaller and obtuse is larger. So it must be acute. That means our degrees will fall between these 2 numbers. So if I take, again, my protractor, I find my point, my vertex, and I set it on the vertex, remember, I can't even see this other line because that line is lined up on my 0. You want to make sure you're lined up right at the edge as well. See how I originally had it tipped? You could see your 0 right here. That 0 must be on the line exactly. And I follow my line up and I say, it falls between 50 and 60 or between 120 and 130. Well, obviously, if it falls between 50 and 60, it would make it acute. Between 120 and 130, it would make it obtuse. Therefore, it must be between 50 and 60. We already decided that this is an acute angle. So then we just start at 50, and we're halfway between, but see these little lines right here? They're all worth 1. So 51, 52, 53, 54, 55. It's about 55 degrees, which makes sense because it's acute, which is less than 90. And the last one we're going to look at is this gigantic one down here. So we ask ourselves, is it acute, obtuse, right, or straight? Well, we know that right goes straight up. And if it's bigger than a right, we automatically know it's obtuse. So it's going to be one of these angles, one of those degrees. So if I go ahead and I put my protractor down, again, finding that perpendicular point, the vertex, setting it on my angle's vertex, which is right here, and lining up so that this mark is the 0, is directly on the line. And I'm going to follow my line out. My options are 50 or 130. Well, since we said it's obtuse, does 50 fall in here anywhere? No. So it has to be 130 degrees. Now I can check with multiple protractors. I'm just going to check with one more, because this will be the other one that you have access to. And I'm going to take this vertex point right here in the middle, and I'm going to carefully lay it on top until I touch the vertex of my 2 lines, and I put it down. Now I remove my pencil, make sure my 0 is lined up with my line, and I follow it up to see where this line extends through, and it looks like it extends right through 60, just like I said. If you can't see your lines, you need to take your straight edge and you need to extend them further. Let's go ahead and try D. Again, through the hole, my 0 is on my right. I find the vertex of my angle, put down my protractor, line up my line, and I look to see that the line falls between 50 and 60. It is 55 degrees. I'm lucky because this one doesn't have the 50 to 60 or 120 to 130 because it's a circular protractor. But if you have just a half a protractor, they have to be able to fit all those numbers on there. Now, the last one, again, pencil through hole, touch your vertex, line up your 0 line, and look very carefully. If you fall in between here, it looks like it's about 130, maybe 128. It's 130. Your reading should be within a couple of degrees. Within a couple of degrees. I said 128, that would have worked. The last thing I want you to look at is, this is actually on our problem set, and if you were to look at this line, it says use a protractor to measure each angle. Remember, we're measuring this angle, what it has arced for us. We can extend the length of the lines if we need to. When I extend the lines, does the angle measure stay the same? Absolutely. I'm going to take my protractor. I'm going to find my vertex between my 2 lines that are perpendicular. I'm going to touch this vertex right here at E, at point E, and line it up with mine. Now I can't see either of the lines because they are directly on this. And if that is the case, it looks like this is pretty close to 180 degrees. It's about 178. It's not quite on that bottom line. So it's almost 180 degrees. Does not matter how long I make my lines, as long as I extend them from the line that was given to me, and I don't curve at the end, whoops, it will still measure the same. And I can show you that by putting it back down, vertex lined up. It's about 179 degrees. Not quite to that 180 mark yet. I could also take this, pencil in the middle, touch my point E, make sure my 0 is lined up on the given line. See how I extended it helps me? And it's almost to that 180. It's really, really close. If you said 180, we would say it was okay.